Welcome to the session 12B as well as lab 7. Because yesterday we dropped off a little early, so I thought I'll cover a little bit of inheritance today before I discuss the problem for today. I will explain and describe the thing and show you a running program. Then you can start working on the later half of the lab today. We'll have a break and then you can continue to work. And I want to ask you whether similar to lab 6 what we did previously, lab 5 or 6, I don't remember. Do you want a bonus for today's submission? Okay. Anyway, assignment is there, submission is there, but if you want bonus, let me know. Maybe those who can do early, they can get some early bird offer. I leave it to you. You can tell me during the lab, okay, after the problem is discussed. Okay, fine. Now let us start with some theory. I will cover something what we touched upon yesterday. I did not put it on the slides, though it is in the slides in the demo yesterday, which were about class attributes modified by objects, which I already spoke about. Oh, sorry. Then both class and instance attributes. Okay, both we will see today. This was done in yesterday's session. I am back referring it so that in case if you want to look at the sample demo, you can look at the previous session recording or the code that we have written there, because this is theory is coming here. I always leave some cross references so that you can understand it better. Okay, we have already covered these topics yesterday. I will just summarize it. An instance attribute is a variable belonging to one and only object. Okay, an instance attribute. Instance variables or attributes are only accessible in the scope of the object, and they are defined inside the initialization function of the class. But you can also do it with other functions also, which we saw. We can keep introducing it, but that is not the right way of doing it, because if you don't call the function, then you have seen that yesterday that is not available in the object as an instance variable, and then you get into trouble if you call another method which is expecting that variable is available. So that's a dependency which we put on some other function or a method being called. So a good practice is to have all the variables related to a particular object, all the object attributes in the init function, so that when the object is created, you get those instance attributes also created. So that's why I've written only init, but it doesn't stop you from introducing new instance variables in other methods. A class attribute is a variable that belongs to a class and not part of any object. They are shared among all objects of the class, and they are in the class scope. Very clear. Each class and object maintains a dictionary of class and instance variables in a magic variable dict, which are part of the class and object instances. Okay, this also we saw yesterday. We could print it, content of the dictionary, which is nothing but the labels and the values that you have initialized them with. When an attribute is accessed, okay, this is the important thing which we saw the repercussions of this. Let me read it. When an attribute is accessed as a property of an object using dot. When I say as a property of the object, we are accessing it with respect to the object and then a variable. Now this variable could be either object variable in attribute, which was initialized maybe in the init function, or it could be a class attribute also. So when you are accessing a class attribute which is having a class scope and available for all the objects of the class, using the object as a label object label, if you are accessing it, then it becomes a part of the object. So you are saying that it becomes a part of the object, and when you initialize it with some value, it creates a new instance, and it is no longer tied to the class variable. It becomes part of the object attribute. Okay, that's what I'm trying to say here. Now, when an attribute is accessed as a property of an object convention, it is first searched for inside the object. So suppose if you have already accessed it once, then it would have become part of the object, and then when you are accessing it with respect to object, then that variable will be seen in the object. So it first searches, the interpreter, when you are accessing it, it searches in the dictionary of the object, okay, not of the class instance variables. Okay, and if it is not found, then in the class, then it goes into class dictionary, and then it searches for that variable. So when you are accessing a variable, it could be in the class or it could be in the object based on whether you have initialized it with some new value. In that case, then it becomes a part of object. Then next time when you are accessing it, it will catch it on the object level itself. But do not think that if you have a class attribute and then with the same name you have an object attribute, you cannot access it at all. You can access it still within this, after creating this object attribute of the same class attribute, by using the class name. You can say a dot something class name. If you say, then it will be resolved as a class attribute, and it doesn't access the copy of that which is being maintained in the object level. So you have to have a clarity on how it is internally maintained by Python when you have a class attribute and then which is overridden by defining it using the object ID. Okay, then it becomes part of the object. So the searching happens from the object to the class. If it is not found in both, then attribute error is raised if not found. Okay, so if an attribute with the same name as what is defined in the class, if defined in both class and object, based on how it is accessed, whether you are using the object identifier to access it or a class label to access it, it will either access the class attribute copy or an object attribute copy of it. Based on how it is accessed, the value of that attribute is returned. I hope this is clear. This also we saw yesterday, so I'm not going to show you that. We have already seen an example of that. When an attribute is accessed as a class property, that means you are using a class label, or you have not created an object copy of that particular class variable, then it is searched for directly in the class namespace. If you are accessing it with a class name, it will not look into the object dictionary at all. It will directly look into the class dictionary and then access that variable's name, or whatever is the value stored there, it will give you. If not found, of course, it is raised an error. So if you are accessing it with a class label, even if it is not found in the class label, if it is not there as a class attribute, then it is going to give an error. It doesn't matter whether you have the same name as an object attribute, it won't be going back here. Once you are accessing it with a class label, it will only look into the dictionary of the class and then look for that variable in the class scope. So even if you have the same name variable in the object dictionary, it won't be accessed. Okay, it will give an error if it is not found there. So I think this is clear, which if any doubts are there, please come online. Okay. Now, what about modified? That's what I told you already. The class attribute is shared between all the objects of the class. However, when a class attribute is changed as a property of an object, that means when you use the same name of a class attribute and then you assign something, you are actually overriding the variable which has been defined at the class scope level into the object scope. And the searching happens from the object scope first and then to the class scope. So by accessing it using the dot operator with the object, a new instance of the instance attribute is added to the object. So that's why yesterday, if you have seen, I think we saw a black, brown, or some dark brown, I think. If you assign, okay, I will give you an example. You have a class variable, okay. You have assigned a value dark brown, and then this class, whatever the class A or something, you have an object you have created A1 equal to A. Now, if you are accessing A1 dot this class variable, and then you are assigning the same string. Now what happens is, I told you that no, the interpreter optimizes the strings with the same content, with the same object. In that case, they both may be pointing to the same string, but internally the interpreter maintains a separate copy for this variable. Now it becomes a property of object, and this gets added to the dictionary of object A1. A1 dictionary, this variable gets added. So even if the dark brown happens to be the same ID, the same string, it's because of the order in which the variables are searched. First object level dictionary is searched and then the class level dictionary is searched. You will not access this class variable. You will access the version of that at the object level. Okay, so that's a little bit of internal implementation, wherein even if you have the same string, it doesn't mean that this variable points to this. Okay, because the resolution stuff. So even if you change this value to something else, this will not get reflected because it will still, this string will be still there in the string or data area, and it will still continue to point, and the dictionary of the object will continue to have. So you don't have an issue that any changes happening to the class variable affecting the copy of that at the object level. Okay, if you have created your own copy of that class variable at the object level. So that's what I mean by this mutable or a modified object. Okay, it's not mutable object. String is not a mutable object, but modified object. So thus any changes done by the object will not be visible to other objects of the same class. So anything that is done within the object A1 is visible only to that object because it is maintained in that its own dictionary, and A2 may have its own copy of that variable, even if it is a class variable, if it has modified. So they will maintain two different copies of them, and they will be available in two different dictionaries. So you will not be having any clashes. The class attribute continues to hold the old value. So class attribute will continue to hold the old value, and it continues to be in the dictionary of the class level, and the objects can have their own copies of those variables. So to effect changes to a class attributes, they need to be accessed using class name. Suppose if you are interested, after having overridden the class variable, and you object 1 wants to maybe make a change to the class variable, it should be accessed with the class resolution. Then it will be actually making a change to the instance of the class attribute. Any changes done to the class attribute are not reflected in the copies of those class attributes in the objects that get created after the changes were done. So once you create a new copy of it, any changes that you do on the class level will not be affected, will not be reflected on the object copies. And after making changes to the class label, if you are creating a new object, then new changes, whatever has happened, will be seen in the newly created objects. That also we have seen yesterday. Since the class attributes are default public, they can be accessed directly also through the use of class name and need not have to be accessed only through class methods. So as I said that we have all the attributes of public in Python, and you can either access it through class label or you can also access it through the object label. Okay, they do both point to the same thing. The thing is, what happens, okay, maybe I will tell you, you have a class label, class variable, class var. Okay, it is in the class A. Now what is the difference between accessing the class variable using A, and then suppose you have a A1 object A, and then accessing it with A1 dot class var. Okay, assuming that A1 has not modified anything. Okay, after creating a object A1, I have not done a class var equal to something. Okay, I have not done it. Can you tell me, anyone, you can come online, or I need to go back to the chat window to see your answers. So Baby, please tell me online, is there any difference in accessing the class variable which is defined at the class level at class A, and A1 is created, and I am accessing A1 dot class where. What I want to ask you is, from the interpreter perspective, is there any change at all in between these two accesses? Can someone, I don't know if I am not clear with my question, please tell me. Is there any difference between these two accesses, whether you are accessing it using class label or using the object label? Is that my question clear?
Yes, sir.
Yeah. What is the difference from the interpreter perspective? Okay, let me rephrase the question. If I print the value and assume that the class var is equal to maybe CV, will I get same value?
Yes, sir.
Okay, fine, that is true. You will get the same value, but there is a subtle difference between this and this access. Can you tell me what it is?
So this A1 is an object, and this A1 dot class variable is basically pointing towards that object, which is also pointed by the class variable.
I agree, but in case, suppose if you are to measure the performance of this or the speed of access of this, will there be any difference between accessing it using this and this?
So at object level, it may be faster.
Okay. Anyone else to contradict him, her, or support her? Let me give a clue. Where is this class variable now? Is it in this dictionary or in this dictionary or in both?
In capital A.
Okay. So you are saying that it is only in this dictionary. Okay, correct. Now come back to the question. Is there any difference between accessing this and this using a class label or object label? Is there any difference in the performance? Now, whomever answered that this will be faster compared to this, do you want to rethink it based on what has been found here?
Sure, maybe it will be faster for class because the variable will be assigned when the class is created.
Not really. Actually, yeah, um, it is faster. Okay. The reason is, as I mentioned, that the interpreter, when you say A1 dot class var, what does it do first? It doesn't know whether this class var is available, modified by this object, and then it is available in this dictionary or not. So I told you that it will first try to look for this in this dictionary, and if it is not found, it will go there to look at the class level, because it is there is a possibility that this class var can be found in both the places. Okay. Now in this situation we have not modified anything at the object level, and the reason that the interpreter goes from checking in the object level dictionary first before going to the class level dictionary, accessing it using a1 dot class var, though it gets the same value in both the cases, this will be slower because it searches in this dictionary first and doesn't find it, then it goes here and finds and prints the CV. Whereas if you had used this directly, it looks for this in dictionary and finds it and prints it. So this will be faster compared to this. Okay, that should be the reasoning. So yesterday someone asked me what kind of questions I'll be asking. Maybe I'm getting an idea that I should ask such questions. May not be the same. Maybe that will be a good thing to ask you to understand your fundamentals of this. Okay, do you understand now why I'm saying that the performance of this is little slower compared to that?
Yes, sir.
Okay, thank you. Okay, so let us
But
go.
sir,
Yeah,
one question.
yeah.
Sir, in case I have modified the object variables, then
Okay, then anyway, the interpreter is going to look for this dictionary first, and it is going to find it. So you will not have a difference in the access speed. Only thing is this, if you have modified it up to CVA, okay, and then this still has value of CV, then when you print it, it will be this, and when you print this, it will be this. But if you are to compare the performance, it will be the same because it's only a dictionary search, only single dictionary search. It's not the double search. Do you get it?
yes, thank you, sir. Yeah.
Okay, thank you. Okay, good. So let us now go to the, I think that's what I wanted to highlight it here. Let us talk about inheritance now. I'm sure all of you are familiar with that. Parent object or a class, and then a child class inherits that. Whatever is defined here, what all can be there? As far as we have learned now, class variables could be there, some methods will be there, and some object level attributes also will be there. Now, what happens when you inherit? Okay, there are some nuances are there which you need to understand. I will explain that maybe today or maybe tomorrow. So this class variables are default inherited, okay, by the child, but whether all the object variables that you have it at the parent level will that be inherited or not depends on something what you do. Okay, that depends on the overriding of methods and the init methods in which you are defining your object attributes. So there are a lot of dependencies are there. I will not cover it here, but maybe those who are already familiar with Python inheritance, they would know or they can think about it. Let us not talk about it now. Okay, now I'm saying a person is a class and an employee is another class which is inherited from person. So this is the object hierarchy diagram. The arrow goes from down to top. So inheritance is the capability of one class to derive, means this class to derive or inherit the properties from another class. It is an excellent way to reuse the code. Okay, basically it is all invented for reusing of code, and even libraries somebody has prepared, we can just inherit it and use it. The class that inherits, this employee inherits from a parent class is called the derived or a subclass or a child class. This is derived or subclass or parent class. This is a super or parent class, super class or whatever. Now inheritance is creating a new class. Again, remember that in Python everything is an object, so it is going to create a new object, and then it is going to take a parameter which is the parent object. Okay, so inheritance is creating a new class from an existing class, and then some additions. It's not them. Okay, I will correct it. Then some additions or changes are made on the derived class. Multiple inheritance from more than one class can also be done. Okay, you can also have multiple inheritance available. Okay, so let us not go to multiple inheritance today. That is reserved for tomorrow. Today, because we have a lab, I thought I will just introduce the inheritance today, and then we will stop and then go to the lab. Okay, so let us start a sample code, whatever we discussed now. So let me take, I don't know whether if I am copying it like this, you find it difficult to follow the code. So I always have a doubt. So let me take some time so that you need some time to observe the code, right? I'm just copying and explaining. You may find it difficult. So let me show you. I am declaring a class person. I declared an init function, which is a method with a double quote. That means it will be automatically called when an object of person is created. After creating that object, it is passed as a self. Now, yesterday we did not pass any other parameter. I thought, I don't know. Okay, name. So if I am passing another variable name, then how do I create it? Now, person is a class, and I pass this parameter. Now, this self is not needed to be mentioned here. Okay, this self has a value or a meaning only if it is within the class. Okay, this word makes sense only within the class. Okay, outside the class, self doesn't mean anything, because you cannot assign a value to the self here. Okay, anywhere outside, unless you have a variable or a label called self somewhere in the global, which I don't want you to do that. Only within the class it is making sense, because when you come into the class, you will be coming in for creating some object, or maybe it is not for creating a just a class object. But when you are creating in a really created an object, or you have already created, or you are creating, then you will come into this one of these functions you will call. Then the self gets assigned the object that you have created, or with reference to any object you are calling it. So self gets a value that time. And now, when is the init called? Init is called when you invoked a creation of object. So this object is already created, and that created object is passed as a self into the init function. So it's like another method. Okay, only thing is this method is called by like in C++ constructor is called automatically. This init is called automatically when you have this. Now a name. So you are passing one parameter name, string. So that is this variable or a value. So that gets assigned. Okay, that's the order in which things happen. I'm sure this is easy to understand. Now let us inherit it. Okay, whatever I showed you in the PPT. Now employee is derived from person. Now this is not like what C++ does. It's colon and then the name. Whether you are inheriting it as a public or private, those things are not there. You pass it as a parameter, because it makes sense in Python, because even this itself is an object, class object, and this is also a class object, employee class object. So it receives a parameter which is a person object. So it actually gels well with the way Python handles these classes. Now you can have a init. That means whenever you create employee, init will be called. Now I am saying name, employee ID, and then self name. I am creating maybe another variable here because it's an employee, and then I am creating this name. Now this name and this name, are they same? They are not. In fact, this name is not even created, because see here, what I do here by doing init, I am overriding this init by this init function. Okay, it's like even when method is being invoked, the order in which they are searched for is again at the class level and then to the parent. So like how class variables are searched for in the dictionary, it is going to be searching for this init function here when it is created. In case you are not done at all, this function is not there at all, then default it will going to look for that init here. If it is not found, anyway it will not bother. Okay, there is no init at all. But if you have called here, it is not going to call this as well. Okay, in C++ we have a notion that the constructor of the parent is also called, and there is a different syntax also to make it with specific, because you have overloading of those, and we will be expecting the constructor to be going in this sequence. But here what happens is it stops with this init and it doesn't call this init at all. Okay. Let us prove it. Nothing is proven unless we see it. Inside person init. Okay. So let me copy this. I want to prove that it is getting called. I hope you can follow. Inside employee init. Okay. Now what I am doing, I want to verify whether default when it is calling this init, does it go to that init and gets called also or not. Okay, that's my worry. Okay, or I want to know then what will happen to this name. You have a self name here and then self name here, because this, if it is calling both, the self is going to be the same object which has been created here. Okay, so you cannot have two names in the same level at the object level. Okay, because both are with respect to the object, so they are object attribute. Okay, they are not class attribute. This is not a class attribute. We are again calling it as an object attribute. There is nothing at the class level. The scope of this name is also at the person's object attribute, and this is the object attribute of the employee. Now I want to create it with the two variables. Okay, this I am adding it only now, no problem. Employee ID is unique. There is no same name there in the person. So let us see. Now I am just putting this so that you know what is being called by invoking this. Now actually I should do that little here. Okay, I will do it here so that we will know what is getting called when it is invoked. See here, it is called, when I created the employee, it has called the init of employee, but it did not bother to call the init of the person. Okay, but that doesn't mean that, don't think that the person is not inherited. It is inherited. Now what does it mean? If it is not even calling init, that means there is no effect of this person object inside being inside the employee, because there is nothing else is there. But in case if I have added one class variable there, that would have come here. Okay, that I will do it next, but I'm just explaining you. This has a meaning. Inheritance has a meaning here, but only thing is I have not put any class level variable here, and this init method is overridden by this init method, and dictionary, when it is searching for this init method on invoking the employee or on creating employee, after creating the employee object, it finds this init here, so it will call this and go off. Now how do I force it to call this init? You have to call super. Okay, then you are saying that I want you to go to the super init and then call. Okay, that we will come to that later. Right now this is what is happening, and it gets initialized with this value, whatever you passed, E1, and it is done properly. Okay, I hope this is the order in which it is called and how it is invoked, you are clear, and why the init of this person is not called is also clear now. Okay, please ask me any doubt in case if little faster. Now let me show you another one. This makes life easier, I felt. Okay, I don't need to waste time on typing, and you will be losing patience till I complete typing, and then I make error, and then I go back, edit it. It's really painful to watch someone doing it. Okay, now what did I do here? What is the difference here? Again, employee only is changed. Person class is not changed. I am calling this as an employee again, so you know that it is resolved here. Then this employee class only will be called. Now what is the difference between that and this? Even I forgot. Okay, I am calling this. Okay, so let me do one thing. This is not there in this, so let me put it and then call you. Okay, and then explain you. Now what happened? I am going to create an employee. This class is defined, so it is going to, now new definition has come to the label. See, always that interpreter, not like a compiler which looks at everything and then resolves the labels. It goes in the same order. So till here it was having the employee label as pointing to that class object. Now a new class definition has come, so this employee will refer to this immediately defined class object. I think by now you are clear about it. So I am having an inside of this, so naturally it is going to call this. Now I don't want a name here, okay? I want to use the name which is there in the person, okay? So if I want that init to be called, I need to specifically call it with the class name, okay? Now remember, whenever I am calling a method which is defined as a self here, it needs to be invoked with the object in reference, okay? Or object should be passed. If you are calling it with a class reference, you should call object should be passed, or you can avoid this parameter when you are calling it if you are calling it with reference to a object, okay? So now inside of this I am calling it with person, okay? That means class name. Then I am passing a self because which I received it, because I am calling it with a class name, and specifically I am calling that init. So this name is getting initialized or assigned to the object at the person level. But as far as the employee is concerned, both are object attributes, okay? Now you don't see any difference in the, of course, name values, but you see that both are getting invoked. Now I suddenly thought about this, okay? I'm going to make some small change. You tell me whether it is okay or not. So do you think is this is fine? When I'm referring the calling the init function with reference to an object, because this is self itself is an object which is of type employee, which has come in here, and I'm invoking the init with the employee. Now what will be called? Will it call this init or the person init? Will it get into a recursive loop? Okay, we'll see that. Okay, now what happens is it is expecting a okay, I have to pass a variable. Okay, I think passed it. Init missing one required operand. Okay, where did I do 41? Can anyone tell me what is happening here? Why is the error?
Sir, name is not assigned.
No, sir, it is actually trying for recursion and taking only one variable.
Very good, very good. Yes. So this is what I wanted to check, because this, okay, is very intuitive, okay? What is self? Self is a object of employee type, okay? So when I call, that's what I thought when I'm writing it, I thought it is going to be going into the recursion, but unfortunately or luckily we had another variable, so it is trying to call this init, okay? And it says that missing one required positional argument. So it is not saying I am missing two arguments. That means self is taken care of, okay? When I'm calling it with self, the first parameter self to this init is taken care of. Name is now mapped to this, but it is looking for an employee ID now. The reason that it is looking for one more required positional parameter shows that, or not the reason, the fact that it is looking for one more required positional argument is that it is actually accessing this init, and it is nowhere going there, okay, accessing the person. So there is no way you can access it and without this person being used for the class, okay? And then you need to pass a self also specifically, otherwise it will say that one argument is missing, okay? So should I leave it with the no, I will remove it, okay? In case if you look at the video or something, you can remember it. I don't want to clutter it. Now maybe one more thing we can try. If I remove it, I am going to have a problem, okay? It's going to ask for one more positional parameter. Just we will try that before we proceed further. Of course it is going to, now it is also saying missing one required positional argument. Why? Because I am calling it with a class name, so it expects self to be there. Now what happens is when it goes into init of a person, it is going here, and then it is mapping that first argument that you have passed name as a self to the self, and then it is asking for this. Now I am going to make one more change. Please remind me if I don't change it later on. Okay. Now, what do you think will happen? Okay. I am going to open it for you. I made a small change here. I made it as a keyword parameter. Okay. And then I am going to run this code without any change. What do you expect to see? If you don't understand, then I will show you again. Okay, let me explain. I am calling this init with the person, which is a class name, with one parameter, which is name. I don't need to pass self. When the interpreter is looking at this, it is with the class name, and init is passed with one parameter. Okay, I'm not passing self intentionally. Now, what I have done here, I have made this a keyword parameter. That means what? My person init, the init defined in person, expects one parameter only. Okay, I can call this function, this method, even with one parameter, because this is a default value. Okay, you can, when it is going in, it will have a default value null. But my question is, will it go through or not? Will I get the same error like this, or will I get something else? That's my question. Or will it have no issues? Anybody wants to give a try? I am expecting something. I am not sure whether my question is not clear or what I am asking, you are not able to get the answer. Okay. I wanted to explain, but okay, anyway, let me run it. Can you tell me why is it happening, at least?
Because then self is, we are passing the string and self is not assigned in the init now. So self is a string to make.
Okay.
It's not an object. That's
Very good, very good. Yeah, you are right. So now you can think what is happening at the interpreter level. When I say a class name with the init name, it did not give this error. A previous error, what was that error? Missing one argument did not come because init is expecting either two parameter or one parameter, because there is a default key argument is there, default value is there. So it clears this hurdle. Okay, this clears this hurdle. This error doesn't come. But the problem happens when it goes inside. Now you are calling now this init with one parameter, which is taken as a self now. And anyway, name is not a problem. It will be assigned as null character. But self is now the string. What you are coming up with a string, it's not an object anymore. And it is trying to get a name there, which is not at all possible. Okay, there is no method or attribute with this name within the string. So it gives an error. Okay, that error is different, but the reason is this. Okay, so I will undo all this. I hope this is clear. Unless what did I do? Oh, sorry, I should not delete everything. I should not put a default parameter, which I did. And then this error, I should put self. Okay, then everything will be fine. Okay, fine, good. I think you have got it. Now let me explain. What did we say? 3, yeah? We went up to 3. Okay. I'm going a little slow because I want to make sure that all of you get it. Now, I access the parent init using the person, okay, this parent. Now there is one more way of doing it, super. Now super, again you need to use this dot init, okay. Now what is happening is, when you do a super here, this is a super of self, okay, and it is inherited from person. Luckily there is only one class from where we are inheriting it, so it refers to person here, okay. It is person object, okay. So because you are using that super, I don't need to use self here, okay. Whereas if I use class name, I need to use self. Here use of super has a reference to the object being created, this object with which you came in. So it is resolved, it is default passed, okay, because you are calling it with respect to an object now, but you are calling it the object copy of the parent, okay, the init of that. The self is default passed, so you don't need to give two parameter here. Actually, if you give two, it will give an error, okay. Now let us run it. It works fine. So now we have done the same thing, but only thing is I have used this super, and then I told you that self is not needed. But what if I do self here, which I did not try? What do you expect to happen here? I don't know. Interpreter could be intelligent enough to ignore it, or it could be strict enough to say that you have two positional parameter, that init is accepting only one positional parameter, and it may give a error. Yeah, it takes two positional arguments, but three were given. That means the thing is, it default passes the self here, and then it is taking another parameter, okay. So that's how the interpreter thinks. Once you have this, you cannot change the logic, okay, the way it has been written, that if you are calling it with an object, is self is passed without you like it or not, and then the rest of the two parameters are passed. It could be the same self, doesn't matter. Then it says that on calling, it says that three parameters have come, but I am expecting only two. So that is the reason the error is like this. So you should be able to make sense out of what is the error and why is this happening. Fine. Now I hope this is clear. Now before I close, I want to do whatever I have done it in the PPT. Okay. Now I have created another employee class. Sorry, what did I do? I am creating the okay. Here from here I have copied. So sorry. So define a company class. Now I have created a company class with a class variable, company name, and then I have one function called set company name, because I given a none here. So I have put a company name and then calling it with company. Now what is this method? This is part of this class, and then I'm passing the company name. There is no self here, and I'm calling it, accessing it with the company, and then its class variable and assigning the value. Okay. Now I'm doing a multiple inheritance like what I showed you, person and company, and then I'm introducing you this dummy variables, keyword arguments. We are initializing all of them, and employee ID is another new thing which is already we had, and then this super is already there. These two are the same from the previous code. I have added this. Now I am passing a company name while creating it, because I know that this employee has a company class also part of it, and it has a class variable. I'm accessing it with the company and then passing, initializing it with this. So I don't need to call this function, but I'm directly assigning it. Okay, I'm not calling this function to do that. And then I'm printing this. So I think it is very straightforward. Only thing is we are inheriting from two classes. Okay, that's only difference. Okay, I hope this is clear. What we are doing, I added a class variable in the new class, company class. I'm inheriting from both. That means the class variable is available here, and then I can access it and initialize it in my init when I'm creating the object. Though it is an object instance, what I am assigning is a class variable, so I don't need to, or I don't want to have this name, company name, as a object variable. Okay, I should not use it with self. Then what happens? It becomes a copy of the object, which is not correct. Company name is at the company level, so I don't want to touch it. So I want to say company dot something only, logically speaking. So this is what we are doing. Okay, I hope this is clear what is happening here. And then okay, last one, please pay attention. Now I think this example I have given you, self is not to be passed if you are calling it with super. So now what I have done, I have called a manager now with the employee. So you can see that the employee is from company and person now, and manager is invoked from inherited from employee. So and manager will have a manager ID. So I am creating a new object ID for manager, and then I want to use the previous whatever was there in it. I am using it, which is nothing but the employee is in it. Okay, so super is always refers to the employee here. Luckily we have only one which is getting inherited. We'll worry about the super when it is used with multiple inheritance, okay, tomorrow. So super here refers to only the first class from where you are inheriting from, and it is init is called with 3 parameters because this has 3 parameters. Okay, I want to pass everything, and the company name is also passing it because company name is getting initialized in the employee only, not in the manager level. Manager is only initializing his own object ID, manager ID, and then I am printing everything. Now what I am doing here, print manager info, I am calling the print employee info. So again you see here, when I am referring the print employee info function, a method belonging to the employee object, which is receiving a self as an input, you know that that method belongs to that object. So I don't need to pass a self here once I am invoking it with reference to an object. So it gets, this self is getting passed by default when the print employee info is called. So that is what is getting passed here, and then it prints everything. Okay, so this is how this works. I hope the whole code is clear, what is happening internally. Any questions from anyone? Okay, now I have a question. Do you want me to explain the problem now or after the break? I leave it to you. You can think about the problem during the break or start solving the problem during the break. But I don't know. If you are in a hurry to have a break, I am fine. Whatever suits you. Okay. Now, very good. Okay. Others, those who want to have break now, I don't know whom to give priority, but nobody has said that I want a break now. So let us explain the problem. Okay, you can even think among yourself. It's not like exam. You can please think about this among yourself also. Okay, it's little some interesting problem to be submitted. Okay, by tomorrow midnight. I am going to give you a template. This is the function you are supposed to write. 2 functions, of course. Actually, okay, let me write it. 2 functions. One to collect the metrics related to a class and at the object level. Okay, metrics. Metrics means what? Now, what I mean by metrics here. Okay, you have a class, you create. Okay, maybe you inherit another class and then instantiate an object. Okay, now you may have some object level attributes. Okay, I'll call it as attributes to be short form. And then you have a class level attributes. Okay, now you may have some class level here. Okay, I don't say class level, some methods defined in the class. I'm not talking about, do I talk about any inheritance here? Sorry, I don't have any inheritance. So maybe I should not confuse you with inheritance. There is no inheritance here. Okay, I am directly instantiating an object. So you imagine you have some class attributes, you have some object attributes, okay, which you have added later on, and you have some methods. Okay, now methods could be only one. Okay, now what I want now, when I say metrics, what I mean by metrics, I want you to write a function, two functions, which is collecting a class matrix, actually print class matrix, and then object matrix. Okay, two functions you are going to write. So these two methods, which are going to be part of this class level. Okay, you don't need to have any methods at the object level or whatever. There is nothing. No, okay, only you can create. There is no methods you can add at the object level. Okay, to be precise. Okay, we should not have even made a statement. So you are introducing a methods in the class level only, at the class only. Now, what I want is, I want to keep track of, okay, very standard question which is asked in C++, number of objects created. Okay, number of objects created using the class. Okay, number of objects I want to maintain, one metric. Okay, another metric is, suppose if I have attributes some var1 and var2, I want to know how many times this variable is modified. In the sense, I am doing some methods. Okay, I am going to have some method which is modifying these variables, class level variables. So if I invoke this method, I will be changing this variable. So I want to measure some metrics, that how many times this method is called. Okay, another indirectly, then you will know that how many times these variables are accessed, or variables are modified rather than accessed, modified. Okay, by calling a method which is also inside our class. Okay, so only thing is, we want to maintain some count of how many times this class variables are modified, or class variables are changed using this method, which is internally accessing those class variables. Okay, very restricted metrics only, not too many things. And then I am having some object level attributes also added by you. So I want to have a matrix at the object level. Okay, at the object level, when I am modifying these variables, accessing these variables, I want to have a matrix at the object level. Suppose if I am calling it with object 1 some method which is changing this object variables, and then object 2 same method, maybe 2 times or 3 times, maybe number of times will be different, but based on the particular object, I should be able to find out how many times this object attributes are modified. Okay, it will be a little bit doubtful or confusing when I am saying this, but when I explain the code and show you the code, it will become clear. So I want you to create, I will not tell you which data structure to use. By now you might have guessed it. I leave it to you. But one thing which you need to think, how will you maintain the metrics at the object level? Okay, that's little tricky. Otherwise, maintaining at the class level is not at all difficult. Okay, once I explain you the code, you will be able to understand. So you have two class attributes and two instance methods. Okay, very simple. I have given you the template code which has these contents. Okay, the class variables are class var1 and class var2, and methods in the classes are my method 1 and my method 2. And then you have a method change class variables. Okay, I told you. Okay, you are having your method also inside the class, the my class, which is getting two values, and then changing these things. Okay, is a method which accesses the class attributes that affect the metrics related to these class attributes. Direct accesses do not affect. So what I want you to maintain, how many times this method is called. Okay, once you know that this method is called, you know that both the class variables are accessed. Now you know that I can also access these class variables using my class dot class var1 equal to something. I am accessing it using class name and it is public. You know that I can access it. But is it possible to maintain this accesses of this class variable in your matrix, unless you are maybe, I don't know, super duper, it's not possible to maintain this accesses. So I'm not expecting you to do that. I'm only expecting you to do, when this method is called, some attribute is incremented. Okay, very, very logical, simple things. Okay, I want you to modify this function to maintain the matrix. Okay, that's all. I'm not telling you don't touch this method, but you should do that. Okay, I'm saying that you can modify the template that I give you, add some code so that your matrix is captured, that this method, how many times it is been called, with respect to a class, okay, or object. Okay, because this is defined in the class level. Even you can call it using the object, because it is waiting, it will search in the dictionary of the object level, and then it will come and anyway find it in the class level, so it will find it. So the init method, you are going to have an init method in the my class, which initializes both the object attributes. There are two object attributes you are going to maintain, and both of them are initialized in the init only. Okay, I'm not doing initialization of any more new object attributes in any other method. Okay, only the init. Okay, only these two object variables. Okay, now this my method, I told you that there are two methods, right? This my method 1 and my method 2, they are also going to be in the class, which I am going to give you. They are accessing those respective object attributes. Okay, they are going to take self as an input as well as some value, and they are going to assign it to the object variables. So now, okay, where to change the metrics related to the object 1 and the object 2 to capture the object level metrics of how many times this variable 1 is accessed, how many times this variable 2 is accessed, because I expect you to use only these two methods to access it, and I want you to modify these methods to put your code so that metrics can be captured. Okay, now write two functions which is to print them. Okay, so you are going to capture the metrics in some data structure at the class level, and then these methods are going to access them, whatever metrics, current metrics are, they are going to print it. Okay, now it is also going to maintain an access count also. Somewhere you need to maintain in your attribute. I will not tell you which function. I am sure you by now you know where to put that metric, incrementing the count. You need to maintain, where is that? Okay, access count is different. Object count, okay, number of objects. Okay, I will tell you. You are encouraged to add any other helper methods needed. Okay, not only modifying these methods or the init function, you are writing this method. You can write some more methods if you want, no problem, to make it modular. You need to add the relevant code in the class, what I am going to give you. Also inside the instance methods, which are nothing but these my methods, and init function, which I have already written to initialize these variables, and any other relevant additional data structures that you need to add it at the class level to maintain the metrics, so that this print classes methods can access them and print it. Okay, they are not object level. Please remember this method is not object level, and I'm sure this metrics also need not be object level. Please remember, this is going to print all the objects in the created so far. Okay, this is going to print all the metrics of all the objects that have been created so far. If you have created two objects, it is going to print all the two objects things, metrics related to that object. So it is also class level. This is also class level. So they are not going to expect any self to be passed to it, and you are not going to invoke them using any object. Okay, you are not going to invoke this using the class name. Okay, so you need to write the code non-intrusively. That means the basic functionality will remain the same, but you are going to add some instrumentation code to get the metrics out of the class. The metrics should also include number of object instances, which I told you that you need to maintain this also. The object metrics need to capture the access counts of the object attributes at the object level, and the class metrics need to capture the count number of accesses of class variables, like how many times you have called this change class variable function with respect to the class. It will be capturing it there, okay, at the class level. So you need to print all of them using this method. template implementation will be shown now, and then it will be seen here. You can use the vars function which I explained yesterday, which will give you the list of object attributes which are there in the dictionary. Okay, but you are not allowed to use any other inspect classes or any other library functions. You are not supposed to use because there are some methods or classes may be there. I want you to implement it yourself, so please understand that. Okay, that's the intent. Okay, now I'm exceeding the time limit. I will finish it fast. Okay, now this is the class. Okay, my class. These are the two class variables. I'm initializing it with some value. I already defined a dummy matrix with a none, which you are supposed to change it, okay, with something else. You have to code it something else, and then change variable has been defined. You are free to add anything to it. It is going to access the class variables of both the variables are getting accessed here. So what I want is, whenever this change class variable is called, I want you to maintain a matrix here that class variable is accessed once. Okay, variable 2 is also accessed one. Okay, that matrix should be updated. And then init, you are going to have an init function which is going to create these two object variables, and it is going to give some values to it. So I want you to maintain number of objects created. Okay, somewhere you have to instrument your code, and then I am having a my method which is accessing only the variable 1, and my method 2 is accessing only the object variable 2. So I want you to add some code here to maintain metrics about this object. Okay, please remember, for this object this method was called 2 times or 3 times. So when I say that, if I am calling this my method with object 1, my method, okay, 2 twice, object 1 twice, whereas object 2 I am calling it this method 2 only once, then the matrix maintained at this level should say that this object var 2 was accessed only once, whereas this has been both, it has been accessed twice. So you need to maintain at the object level your object metric. Okay, and then print my class and print by this should print all the, okay, this will be accessing this data structure and then print everything that it has found so far. Okay, whenever you are calling this, at that moment whatever is the matrix, it will be printed. Okay, so that's the template code. Any questions here? Okay, so I am going to call my class print matrix. This is a print method that we have called matrix before instantiating any object. Okay, it should print something that no object is created, number of objects created is 0, number of there even variables won't be there, so I don't know what to print. It depends on how you implemented it, but at least you should say that number of objects created should be 0. And then once I create object 1, my class, okay, I have created one object, then class matrix after instantiating object 1, object matrix after instantiating object 1, it should be printed. Then I am calling my method 1 now. Then what is the difference you see? So I have put a convention that 2C is class matrix, O is object matrix, and the second, third, fourth, like this. So my method 2 is, I'm sorry, my method 2 with respect to object 1. Okay, it's correct. Okay, please remember my method 2 is changing the object variable 2, but it could be called with object 1 because we have created only one object by now. Now what is that? I am going to call this for in a loop 1 to 5, object 1, my method 1, 2, both I am calling. Then I want to see what is the matrix. So matrix would have changed now based on this accesses. Now I am accessing the class variable directly, okay, which I said that your matrix cannot be affected because you cannot call your matrix method anywhere. So this should not affect anything. So you will see that the matrix, when I print it, it doesn't have any impact. But if I call using the change class variable method, you are supposed to have instrumented the code, so you should change that the class variable has been accessed. Okay, So if I call n number of times, it should be reflected in your matrix, class matrix. Yeah, go ahead. Okay, any doubt? Okay. So this is another strings of method. So I am creating another object of my class. Then it is going to print after my object what is the metric. So it should reflect the metrics of the object 1 as well as object 2. Please remember, because object 1 has been created now. So number of objects created are 2, then object 1 metric something, object 2 metrics are something. Now you should have one more entry now because you have created a new object, and then you are changing the new object, whatever you have created, some more accesses you are doing, then that should get reflected, whereas object 1 related things should remain same. Then you are creating new another object, object 3, then that should also get printed. So, and here I am doing it both class variable as well as this, so it should get reflected in both the metrics. So that's what I want. Okay, so expected output. Okay, now I think I don't need to even show that running code. My class 1, okay, it is difficult to understand now. Okay, how I am printing it, class variable 1, see, when no object was instantiated, class variable 1 is 0, variable 1 is 0, my method 1 is 0, everything is 0, number of objects created is 0. Okay, this all of them are 0. What about the object instantiating? It is just giving you 0. Okay, number of objects created are 0 and it doesn't have anything. Now what about the metrics that I get after instantiating one object? Then I get it like this: one object has been created, this is the class attributes, and the object attribute says that I did not access the object variable 1 and 2, okay, not even once. I created the object, but I have not even accessed it once. Okay, it says that they have not been accessed. Okay, is it correct? Okay, let me see. Now, after calling my method 1, I access it once here. Okay, see, remember, here I am not, you can change it a little bit, in case if you want to maintain the metrics at the init level, that's okay. But this is what is the expected output. Only when you call the my method 1, if you are accessing the object, that object variable using my method 1, I want you to say that it is incremented, it is accessed once, because I am calling method 1 here. And then if I am calling the method 2 with respect to object 1, okay, because there is only one entry here, object 1 is created, so I am saying that both are getting one value because I used it, okay, once here and once there. Okay, my method 1. Okay, so I hope this is clear. And then I put it in a loop with the 4 times, then it gets incremented. The class variable also, the methods are getting affected, but class variables are not affected yet. I have not called it yet. And then these variables are called 5 times because the code says that. Okay, in a loop you saw that 1 to 5, so 4 times it was called. Earlier it was 1 and now it has become 5. So this is how it goes. Okay, I will give you the code and then this PDF also. Okay,